Yeah, right. Tick, 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 tick. Right. By the way, Thursday, everyone's phones are going to go off about noonish, I think, 12:20. Yeah. I immediately looked to see, okay, what time am I speaking? That's
Why is that?
they're testing the national,
Oh, the national.
yeah, the new national broadcast system. Yeah.
That's
So
what
everyone's phone.
well, but it'll go off in 2 or 3 rounds.
Right.
Because if you're ever someplace, you'll notice it seems to align with
Like a
carrier.
wave. Right.
So all the Verizons will go, and then
T-Mobile,
Yeah.
18.
12 seconds later will be all the T-Mobile.
All right, you ready?
Yeah.
All right, thank you all for coming to this class, or this session, the transitions in Civil 3D and InfraWorks design. Russ Nicoloy is the presenter today, and if you want to track your time or your attendance, don't forget to use the code right there on that front place, or on the table right there to log in on the app if you're using the app to track your time. It will only, and that code will only work for 15 minutes prior to the session, and when the session ends, then it's done. So it's only a one-time use thing. So Russ has been in the civil industry for many years, since 1995, 10 years in producing drafting and GIS, and 13 years as an Autodesk reseller, providing subject matter expertise in Civil 3D, InfraWorks, and Autodesk products. He's a consultant member of the Methods Development Team at Wisconsin DOT. His company, Macer Technologies, provides drafting services to the civil infrastructure industry in the Autodesk infrastructure collection of products. So with that, Russ?
Thank you very much. Thank you very much, and thank you everybody for coming today. I appreciate you spending some hard-earned IHEEP time here with me. As part of the 30 years that I was in the industry, a large chunk of that was with a reseller, and I got a lot of experience with the transportation industry through that. Actually, a very broad look at the entire industry through that. I got to work with lots of different organizations, but a lot in transportation in particular. And I think what I'm talking about today is going to settle very heavily on the transportation industry. However, I don't want that to be the closed-in look at this. Part of what I'm going to be talking about is very much about the cleverness with which you can use tools for different things. Some of the things I'm going to talk about, literally, I saw somebody do a golf course design with. So don't just think transportation. Be broad with it, and other things that are around your projects may be able to use these tools. So the agenda for the session today is going to be, first of all, I'm going to start off talking about using subassembly parameters. Now, I'm not expecting this to be a good choice for transitions necessarily. This is something that is going to be kind of the base work for the topic as we get started here, so you understand where these tools are going to be working and how the functionality is going to be drawn into by you or your users. There are some things that you can do with it for the transitions. However, this is more the base plate for what we're talking about. Next is the targeting of alignments and profiles. Now, this is going to be the lion's share of how you would be transitioning projects. It's the bare bones and the basics, but it covers so much territory. I'm thinking I'm going to call 90% of what transitions need are going to be here. Now, I'm going to cover something that's a little bit on the clever side. I'm going to use the term clever several times with this, I think, and that is the super elevation tools. Now, super elevation is great for literally super elevating a roadway. However, I've seen clever use of this to do other kinds of slope management, and I would be remiss in not saying, hey, this is out there. So I'm going to spend just a little bit of time on that. I'm not going to recommend it as a good course of action, but again, if you get a little creative with the tools I give you here, they can provide a good outcome for you. Then I'm going to talk about what I think is the jewel in the crown here, and this is a brand new tool, or relatively brand new tool. That is the new corridor transition tools that Autodesk has built into the 2024 release of Civil 3D. If the alignments and profiles aren't getting you what you need, that 90%, this tool I can't imagine it wouldn't. It's going to cover so much territory. In fact, I think it wrestles some of the territory away from alignments and profiles. Again, just depends on how you feel about it and how what you're thinking about when you're doing a design project. And then finally, I am going to visit InfraWorks for a bit. InfraWorks works very differently than Civil 3D. However, they are closely related. They are separate platforms if you're not familiar. However, a project that has started in InfraWorks can be moved over to Civil 3D. And I think in a great way, because then you don't have to keep redoing things. It takes the project over there. So if you've got transitions that you know are coming, kind of the broad strokes of transitions that you know are coming, and you're using InfraWorks, do them there and then move that into Civil 3D for the final, more granular detail of your project. So a lot of the concept that I'm going to talk about here today is the right triangle. And generally, up to a point, I'm going to be talking about having to compute two legs of this. Either I give you the width and the elevation, that'll give me the slope, or I give the slope and the distance, and that'll give me the elevation or the depth. You've basically got to provide two legs of this triangle, and there's some computations that are going to go along with that if that is indeed what you're needing there. Now, this is going to change when I talk about that new tool. But I'll talk about that when I get there. But this does get easier than what it is for the most part across the course of project work. So let's first look at the subassembly parameters in the corridor. I've got a screenshot here of an orbited corridor. Basically, we spend a lot of time looking at corridors straight down, and you get frequency lines through there. The frequency lines are literally your assembly being applied over and over and over through the corridor. The assembly is also providing point codes so that you're getting frequency line, or what we call feature lines, along the corridor. This is going to be like your crown point is going from crown point to crown point to crown point, and edge of traveled way to edge of traveled way to edge of traveled way. These lines are absolutely straight. So there's no curve to them. You could probably compute something in there, but generally the corridors exist to be straight between known locations. Everything in between is just iterative information or implied information in between. So now, again, great for understanding the construction of a corridor. However, for transition, this isn't always the best way to create a transition. What's going to happen is if I was to expand a lane, let's say, I'm going from a 12-foot wide lane to a 20-foot lane in an area, I could do that very quickly and make the transition area very, very close together so it's a very hard, sharp edge. If you need to make it a long, sloping transition over a long area, this is where this one kind of falls down. It's not great for that particular option there because it is going between point to point directly. So I will show that in a bit here as well. Also, you only have available the subassemblies with parameters that you have. Now, most assemblies are going to have what you need there, but you do have to have that planned out for what you're looking for and what you're going with. So now, like I said, I'm only going to spend a little time on that. I will show some of that in demonstration. However, I want to talk more about the big tool, and that is the alignments and profile targeting for what you're getting. Alignment and profile targeting generally are going to control the either horizontal, that width of the right-hand triangle, or the elevation, the vertical targets. Horizontal targets can be things like alignments, which are all 100% horizontal location. There's no elevation component to them. If you want an elevation component to an alignment, that's a profile. So that's where that division line is. You could also use feature lines or even polylines to target out the width that you're needing for your corridor there. The vertical targets, you have profiles. Feature lines actually appear here as well because they are a three-dimensional line. So you could lay it out horizontally, but then go in and edit it so it has elevation. So it can control both aspects of it. However, again, just like that right triangle, you are computing where that elevation is. So that is really on you or the designer to figure out where that location is. And by the way, keep in mind that elevations are affecting the slope. So if you are trying to define a slope out there, you're really working on the elevations of that right triangle to make sure it's in the same spot. For me, that's a lot of computation, especially in transitions, because I need to hit certain points along a transition and make sure that my profile or whatever it is that I'm targeting is doing that work for me. This is great for longer and more accurate transitions because you can lay that out however you need it to go. Every nook and cranny can be modeled with alignments or profiles or what have you. One problem is not all parameters respond to targeting. And this is where I'm going to talk a little bit about out-of-the-box subassemblies versus subassemblies that you've built on your own. I get the feeling that subassembly composer is a bit of an ignored tool, and I don't think it should be. I think a lot of great things come out of building your own subassemblies that do what you need them to do. Do a lot of work with WISDOT, and at WISDOT we have as many subassemblies that are custom as there are out-of-the-box ones. And each one has a very specific reason for being and a specific control mechanism. Now, you don't need to build your own. You can get away with what's out of the box, and the out-of-the-box ones are actually great. However, they don't always target the things that you need to target for some of the things that you get into. Also, and I've talked about this, controlling the slope factors, knowing the profile elevation and width. So you're having to compute those two legs of the right triangle there. With that being said, let me jump into Civil 3D here. And first of all, let me orbit this again, just to make sure that we're all on the same page and understanding what the corridor is looking like in general. Notice that the lines that are across the corridor here are the frequency lines, and they end up being basically a top-down view of your assembly being applied at the frequency that you are requesting. And you can make that frequency whatever you need it to be, very short together, or if long stretches a highway, maybe 100 feet, you can do whichever one is appropriate for you there. But notice that I am getting lines that are going along here. These are the feature lines I talked about. The crown points are going to the crown points, the edge of traveled way through there as well. Now, if I take that, I am going to show you the assembly that I have in that corridor is this top one. And it's currently on this right-hand side is a 12-foot wide lane. I've told the parameters, you're 12 foot. If it doesn't have targets, it will default to 12 foot. And I have no targets, so it's 12 foot along my entire corridor here. Right below that is one that I'm going to add in, which is a 20-foot wide lane here. And let me drop that in so you can see what that looks like. I'm going to grab that corridor. I'm going to split this region. And then, now I'm going to click a point here that'll add a frequency in, and you can see some grip points because it's actually breaking that into two little areas that I can control separately from each other. I'll come over here and add another one there. And now, I'll go into the corridor properties, and in that middle region, I've highlighted it here, you can see it's highlighting on my screen, I'm going to add in that second assembly that has the 20-foot lane to the right. And I'll rebuild that. And then in here, you can see the width of those rows. Now, if you're not used to seeing this, let me call out where the lane is. The lane is right here in the 12-foot and right here in the 20-foot. Okay. But notice, more importantly, these lines here, where the edge of traveled way and the shoulder, because the shoulder has to transition along with the lane, it's all attached, those are going directly over there. Like I said, this is great if you need a very sharp transition. You just make that space right there, well, I've got maybe 10 feet, make that 0.01 feet, so it's almost a direct wall over there. Great for a hard cut. However, many of the transitions you're going to do are much smoother than that. They're going to be over 100 or 150, 200 feet. Those are not going to be as pretty when you do something like this, because you would have to get rid of a whole bunch of frequencies through here to accomplish that. In fact, I have seen this, and I don't recommend it. Before I do this, I'm not recommending this as a way to do it, but I want to show you the consequences of this action. I can grab these regions and separate them by quite a distance, but there you can see the problem. Okay. Now, this isn't as big of a problem as it may look at first. It's a huge problem, but it's not as big as it may look. The frequency line, or I'm sorry, the feature lines cutting across there have stopped. They don't jump that gap. However, when we build a surface from this, the surface will jump across there. So it is a viable option. But again, I don't recommend it because you are trusting, and I'm not a trusting person when it comes to something like this. You're trusting that the surface is going to do everything that you intend across there. By the way, it also prevents you from using a boundary around your corridor, or at least a boundary that you would probably want to use through there, or an automated one. So it's not the best option for this. But understand that people have done it, they've gotten away with it, especially in the early days of Civil 3D. However, there is a much better tool, and that is the targeting of the alignments and profiles. I'm actually going to go into my section editor here so you can watch this area as I progress through with it. And just so everyone is familiar with the view that I have, if you're not using Civil 3D or if you're new to it, I'm using the section editor so I can see at this station right here where I've aligned, that's what this cross section here is. That's a live view of the corridor as I'm using it here. So we'll be able to see some of the changes that I make live and in real time. But what I'm going to do in this area here is I'm going to make an offset alignment for my horizontal target. Now you can draw this in however you want. I'm going to use the automated tools to do this, okay? It's just one of the options at your disposal. You don't have to do this. You can draw in whatever crazy shape you're having to go through manually. I'm going to go in and say, well, I want this alignment right here, and I'm going to create an offset alignment. Offset alignments always stay parallel to their parent. I'm going to say I only want it for a little bit here. And I'm going to turn off the right-hand side. I'm only going to make one on the left-hand side. And the incremental offset here, let me zoom in on that so you can see clearly. I'm doing one to the left, and I'm going to do a 12-foot offset because my original lane is 12 feet. I want a nice tie-in here. Then I'm going to widen that out so that I can get to a nice turn lane or bus inlet or whatever it might be that you're designing there. So I'm going to go with the 12-foot. I'm also going to turn on the Create Offset Profile because, again, you can create your own profile and, again, make it however you need it to be. In my world, that's a lot of computation in a lot of cases, so I don't want to have to do the math if this is going to do this automatically for me. So I'm going to let the automated tools work for me, but just understand you don't have to. The thing I really love about this is in the Create Offset Profile, you identify what you want that slope to be. So remember that right-hand triangle. I'm giving it the width and now the slope of what I want over that distance, and it's going to give us the elevation on that other leg. So with that, I'm going to say okay to that. That puts the alignment out there. And I should have shown this beforehand, but the red profile here is the design profile. The green one is the offset profile. So over 12 foot, it has created a profile that is that 2% drop over the 12-foot distance. Again, you could build that yourself, but you'd have to figure that all out. And I've met people that could do that off the top of their head. I'm just not one of those people. So I'd like to let this tool do it for me. Now I'm going to zoom back on that just a little bit because now what I'm going to do is widen this out. And you'll see that profile will adjust to the width that I'm giving it. I'm going to go to this alignment here, and I'm going to create a I'm going to create a widening in it. I'm going to say from about here to about here. Not a very wide one, but I'm going to widen it to 25 feet. And there you can see that alignment is built through there. It is building a transition in there which you can adjust. You can grab those grips. You can go into the dialog box and type in a very precise number of where you want the transition to start and end. So you've got quite a bit of control over it. But it is going out to 25 feet there. Now with that, that's at about 1,300. Let me come over here and you can see at 12 feet at 2%, this is where the profile is, and then it starts to transition down to 20 feet, or 25 feet, excuse me, at 2%. So it's doing all of that math for me and putting that profile in where I need it to be. Now, that's one part. I am going to build another one in here, and that is I'm going to go into that same offset alignment, but in this case, I'm going to go into the offset profile properties where we are controlling where that slope is. So if you decide, oh yeah, negative 2%, that's not what I wanted. I wanted negative 3. You can fix that here. It's editable. However, what I'm going to do is I'm going to add in a couple here. I'm going to push a part of my roadway down so I can get into drainage or do whatever I need to hit. Maybe I need to hit a specific elevation somewhere. I'm going to click and add in a station. I'm going to add these very, very early on, 10, 25. And at 1025, it's -2. So I want it to be -2 for a little bit here, and then I'm going to start transitioning into something else. I'll go to 1100. And at 1100, I want that to be a -5%. I'll say I want that to go to 1175, and that's also going to be -5. And then at 1275, so a nice 100-foot distance there, I'm going to send that back to -2. Now, I chose those stations because they do overlap some things, but you can see again, just like we had earlier, you can see the stations and the slopes at each of those stations, and it's all editable. So if I made a mistake and it wasn't far enough or didn't give enough space, I could make those adjustments here again. I'll say okay to that. And now, notice that the corridor really hasn't responded to it. And if you're not familiar with Civil 3D, the lane here is not targeting that alignment yet, so it's not widening yet. Also in our cross-section, we're not getting the slope change yet. And that's because I haven't told the corridor to do that. Let me jump into the corridor properties. And in here, excuse me, I need to tell it that it's targeted to those things. So I'm going to target in, I'm going to go to the left-hand side. I have an outside elevation target that I'm going to target to my profile. And I have a width target that I'm going to target to that offset alignment. And once I have those set, I rebuild the corridor there. And there you can see the lane is now reacting to that. It matches up nicely with that alignment that's in there. Also, if I start to adjust down my alignment there, oh, let me get in so you can see the change. There you can see the slope of that lane is changing. Also, depending on where I am, right here I'm at 12 feet, but I can widen out to 20 feet in width, but that slope is changing across the course there. So I've done a fairly complex bit of targeting in one area there, trying to get a couple different things going on with just alignments and profiles. Like I said, I believe about 90% of your work can be done with just those two tools alone, depending on how you station them and how you put them together. A little bit more computation on your end, perhaps, but the automated tools take care of quite a bit of that for you. So let me jump back in here so I can talk about that a little bit clever tool, the super elevation for transition control. And let me state again that this is not talking about super elevation directly. This is using the super elevation tool in a way that was not really planned on, or at least I don't believe was planned on. I've seen it used here or there. Again, I don't know that I recommend it. There are some things about it that you need to be aware of. But I have seen it used in nice areas that I think you need to know about it at least. So for this, one of the key parts of this is that in the super elevation table, you have 8 columns of information. Now, they're all named for the critical stations of a super elevation, but that doesn't matter. Those names are only there for targeting purposes and so that you understand where you're at and what you're getting. Also to communicate to others where you are and what you're doing. So those columns can be whatever you need them to be. Like I said, I did see this used for somebody who was building a golf course. And they used it to build bunkers and little hills throughout the course of the hill. Never thought I'd see that out of a corridor, but it worked and they used it. So now, like I said, there's some huge issues here. First of all, what if you don't have any curves in your project? Now, this is actually not a problem. It had been a problem back in the day, but Autodesk has addressed that. There's a way that you can put in what's called a user-defined curve. So that problem's really off the list. Now, something that's probably a little more of a problem is what if you have super elevation in your design already? At least some of those 8 columns are taken up. So you've got to kind of plan that out if you are going to use this. Like I said, these tools really are there for very specific kinds of work. And on transportation, they might not do everything that you want to do. By the way, I'm not going to do this, but I do want to call out that I did see somebody do an offset alignment 1/100 of a foot off of the original, and then they built what they wanted to do the specialized targeting for off of that second alignment and built a special super elevation off of that. A ton of work. So I'm not, again, not recommending it, but to be clever, that's what they did to get around needing a super elevation through there. Now, so there are ways around that. Also, if you're not using all 8 columns, you could use the 4 or the 3 that are still open. You can do that, but not a great response if you've already got super elevation. The really hard one here is the last one there, and that is not all subassembly parameters respond to super elevations. And again, I'm going to touch back to subassembly composer, because you could build your own subassemblies that do respond however you want them to respond. Generic links do respond great, or many of them do, to super elevation. So there are some things around this, but generally, I think that's a harder case right there to work through. So let me show you what that looks like, just so that you get a sense of what's available. This roadway does not have any super elevation. In fact, let me go into the tabular editor there and show you a complete blank super elevation table. There's nothing here. Now, I need to call that out because I'm about to put something in here and about to use that for my own purposes. What I'm going to do is go in and calculate the super elevation. There is a wizard, and I highly recommend that for super elevations anyway. It's a great tool to automate that process. You answer questions, it does the geometry for you. However, for what I'm doing, I'm, again, being a little more clever here. I'm going to go down to the Open Curve Manager, and in there is the Create User Defined Curve. That's Autodesk's, kind of go around when you don't have a curve. So I'm going to choose that tool right there, and I need to select the alignment. And with that, now I'll go into that table again, and now you can see there is a user-defined column in there. It's basically a placeholder somewhere where you can add information into. I'm going to go up and hit plus sign. You can add super elevation stations at any point. So if you're doing a legitimate super elevation, you could use that plus sign. And I moved just as I clicked it. There we are. Actually, I'm going to start right at the very beginning of my alignment there. And at that station, now I don't play pool, but if I did, I call my shots. I'm going to add this into the left-hand lane. I'm going to intentionally use the right inside lane column, right inside lane, just so no smoke, no mirrors, so that you can see, to prove a point that you don't need those names up at the top to be anything other than how are you assigning. So I'm going to go to the right inside lane. I'll say -2% there. Then I'm going to add in a plus sign, and then I want -2% to come up through the station about here. And at that station in the right inside lane, now notice it says -1.2. Where's it coming up with that? Well, the whole thing here is that the super elevation table thinks of 0 as its start point, and when I gave it -2 at the beginning, all the way at the end of the alignment, it's still 0. So it's transitioning over a couple thousand feet down to that. So by the time I got to about 51 plus 0, it's at 1.2%. So I just need to go in and make sure that that is correct at -2. Last time it's normal. I'm going to add in another one here. I'm going to say that's 51.25. At that station, I want that to be -5%. And I'm going to just add one more in here at 5,300. And I'll say that's -2%. And again, I would add another station at the very, very end to be -2. That way I have a normal -2 all the way through the rest of my design. Notice all of these columns are editable. If they're kind of this like goldish color, then it's a locked field, but generally slopes and lengths and end stations. Also, the names are editable here. So in this case, these are not critical stations. I'm going to add in, this is my alignment start. I like to label these things, first of all, because my memory is terrible, but secondly, because somebody else might take this project over from me and they won't understand what's going on here. Hey, there's no super elevation on this, what's going on? They can read these out and say slope start. So those names don't have to be anything specific, but they can be that reminder, that REM code for you to remember what is what throughout the course. I'm not going to fill it all in here, but that is now assigned to this alignment. Now, the corridors all, I always call that, got angry. They're like, hey, something's changed. I don't know what. You need to rebuild me. I'm not going to rebuild it quite yet, though. I do want to go into, I'm going to go into station 5100 here and go to my section editor, again on the left-hand lane. What I need to do here to make that slope appear on the left-hand lane is tell the assembly that I'm using, or the subassembly part, what it's targeted to. The lane that I have here, when it's placed by default, I placed it, it had a use super elevation set to none, which means it's literally 0 or -2 if I've given it that. It's going to be not responding to my super elevation table at all. Doesn't matter what I put in or where I put it in. I'm just going to go in and tell that particular station that it's the right lane inside. Remember, I called that one earlier. Right lane inside. I'll say okay. And now I'm going to rebuild all the corridors just so that they all are comfortable. And there you can see we're at 4% at this particular station. I can advance. I'm at full super, right, or full super at 5% there. And now I go back to 2%. So you can see it's now responding to that. The right-hand lane isn't responding at all. I haven't turned that on at all. I could set it to the same right lane inside, or I could set it to something else if I've decided to use that at my disposal. Like I said, it's a little bit clever, something that you can get around issues with. So just something to know exists out there. Let me now talk about the corridor transition tools. And like I said, I think this is a game changer here. If alignments and profiles are doing 90%, this is doing at least the last 10%, maybe the last 9.5%, maybe even more, taking some functions away from the alignments and profiles. You just don't need to use them. Because we've got this conceptual shift with this tool, that right-hand triangle that I showed you earlier, you no longer have to give 2 parts to it. This tool targets directly the parameter that you actually need to transition. In this case, I want grade and slope. I don't have to give it the distance and the elevation anymore. I can just go straight in and give it a slope. You're going to see in a little bit here, I can also do depth of material with this, which that's a transition that was always pretty difficult to handle. And this will take care of that. So again, the elevation, well, it's now a depth in that case, but it's still targeting that parameter directly. So now this tool, by the way, if you have used Civil 3 in the past, you're not on 2024. A lot of times organizations won't adopt it immediately, so you may not have seen this. If you're in 2024, this is available to you right now. Out of the box, it's available to you. If you haven't seen it yet, though, just understand that this is something you need to look at in 2024. What you do is you first of all just select the corridor that you're working on. You select it to make sure that you've got that. You go into the context ribbon and turn on the corridor transition tool, edit corridor transition. Then in a top-down view of your corridor, you identify which subassembly you're working with. Now, I think this is a little bit of an inventive way to identify a subassembly. A lot of times a list comes up and you have to pick which subassembly you're working on. I always pick the wrong side or the wrong one, so I like the graphic option. It really helps me, honestly. Then you will get to the parameters, and the parameters are this list right here. Now, this parameter list is going to be specific to the subassemblies that you're using in that area. So you're never going to get too many things. You're never going to get something that's not going to work. You've got access to all the parameters that are available to you there with default slope, pavement 1 depth, pavement 2 depth, and so forth. All those in this particular option. Different subassemblies going to have a different list, some shorter, some longer. You will then identify the start station and the end station of your transitions and kind of bracket those in so it knows where it's acting. And then finally, you can provide a transition type. Linear is the default. It goes from point to point. Just like that first look that we looked at subassembly parameters, does something very similar, but it does a transition between them, so it's much smoother over longer distances. But things like bay taper, cubic in, cubic out, parabolic in, parabolic out, and reverse parabolic are ways that you can fit curves into that transition. So again, you could build that alignment yourself, but this is going to automate that process and make it much more mathematically correct for the different types that are usually used for things like this. So let me jump into Civil 3D here, and I'm going to select on the corridor, come up to the Edit Corridor Transition. It's in the Modified Corridor panel if you haven't seen it. And then in here, notice as I move my cursor over the corridor, I'm identifying the different subassemblies. Now, again, I will choose the wrong one if I don't, if I'm not careful. If you're doing a curb and gutter, they can be small. You got to zoom in a little bit maybe. But it will tell you, notice that my tooltip there is indicating what subassembly I'm actually picking up. Now, honestly, normally I make my quarters with lane super elevation AOR-L or -R, so I can tell it by the name. I didn't do that here, but I can still see that's the right-hand lane. So I'm going to identify that, and as you saw before, there are the parameters for that particular subassembly. I'm going to pick width here for the beginning part here, and I'm going to pick a station to start. Let's say 8300. Now it's telling me up here at 8300, normally it's 12 feet. It's not putting that number in, but it's telling you, hey, normally that's 12 feet. What do you want it to be? I want that to be, I do want to start at 12 feet. The end station here, that's 8300. I'm going to go to 8350. And at 8350, I'm going to go to 20 feet. Then I'm going to add in another one. I'm going to insert a transition below. And notice the start station picks up the end station from the first one, brings that over so you don't have to retype that. I'm going to come in here and type in 83. I'm going to do 84. And the end value there is going to be 20 feet as well. So I have a little bit of 20 foot in there. But then I'm going to transition back down. I'll go to 8500. And transition back down to 12 feet. Now notice that lane hasn't changed at all. If you just look at that lane, it hasn't moved at all. I have to click apply to make that work. And I'm going to, but I'm going to make this a little more complicated. This is where the juggler starts to add different things into his act. And so I'm going to add some more things in here to make this a little more complicated and probably more realistic. I'm going to add in another section here, and I am going to pick the same lane. And again, you could pick as many subassemblies as you need and make these as different as you need to. I'm going to make this one the default slope, and this one I am going to overlap these as best I can. I'm going to start at 8200, and at 8200 the slope is -2%. I expected that, so I'm going to say -2 there, and I'm going to let that go up to 8300 and make that a -5%. I'll insert another one there again from -5. I'm going to go from 8375, so it overlaps that other one. And I should have pointed this out earlier. Notice the brackets on the screen. I love whenever the tools graphically kind of confirm where you're at, what you're working on, because if you miss something, then you can immediately catch that graphically. When dealing with a lot of numbers, it's easy to get in the wrong space. And I'm going to add in 8475 to get back to my -2%. And one more, because like I said, I want to make this kind of complicated. And for this one, I'm going to do the pave depth. Now, I want to tell you how important this is to me, because on many projects, and I can't tell you how often this has come up, it seems like it doesn't happen all the time, but it happens just enough that it was always just a little frustrating, like, yeah, to transition between that depth and that depth, you got to do some crazy things here. In this case, I can go directly to it. So I'm going to pick pave 1 depth, and I'm going to start that one pretty early on here. I'm going to start that back here. And the depth of that said 0.33, so about 4 inches in there. I'm going to say that I want that to be 8250. Where I'm going to make that 1 foot. Now, I'm making that ridiculously large so that you can see the difference as it transitions. I mean, if you need to make it that deep, then you make it that deep. I am going to transition that back to 8350. So again, it is overlapping the other ones to some amount, but I'm going to put that back to the 4 inches there. Now is where I'm going to pull the plug and make this work. I'm going to click apply, and all 3 of those are active. We can only see the width from the top down, but I'm going to jump into my section editor so we can see now we're on the left-hand side. And as we are advancing through this, we should see the depth of material start to change first over that long transition. And we're also seeing the slope transition here. And let me lock that in. And there you can see the width has changed as well. So I've got three simple transitions, but the way that they're overlapping there makes them a very complex combination. It'd be very difficult to carry out with the tools at hand. So that's the kind of thing that you could do along the entire length of a design. So I'm a big fan of this, and if I got a support call on a project, I would point towards this before a lot of other options. I think I would probably default to alignments and profiles because that's the old standby. But this tool here was going to get me out of trouble in most of the cases that I run into. Now, I wasn't going to talk about this, but I'm going to talk about this real quick, and that is the parameter editor in your section editor. Some people do use that tool. I drive away from it just because it's easy to lose where the transitions are. It's a great tool in and of itself, don't get me wrong. However, it's very easy to lose track of where you're transitioning one thing over another. You're actually putting in very specific parameter numbers, and you are having to do all the calculations. It's very, very manual. So again, instead of pointing you towards that, I'm going to show you where parameter editor is, but I'm not going to open it. I would point you towards the new tool, the corridor transition tool, because I just think it is, like I said, it's the crown jewel at this point. So with that, let me take a look at transitioning in InfraWorks. Like I said, InfraWorks works very differently than Civil 3D, although they ride parallel to each other because you can move data from InfraWorks into Civil 3D. I think InfraWorks is a great tool for a very early design of your highways. Move it over to Civil 3D for the granular editing and the things you need over there. Transitions in InfraWorks add generally, and I don't want to overstate this, but generally by adding components. You can see on my screen there, I'm adding a lane to it. And it automatically adds transitions in and out to the width that you're putting that lane in, so it's handling a lot of that automatically. You can see grip points that you can move them around. You can change the transitions to the very start or very end, so you can make them very long without having to pan, zoom, zoom, pan, zoom, and all of that. One of the things I really love is that the intersections, whenever you have two roads that cross at any point, it automatically creates an intersection and then understands that, hey, you might need a turn lane in here. So if you edit it, it adds that transition in for you. So it's a very smart tool. It thinks ahead of what's generally going to be happening there. Now, you can do different depths of materials. However, it's not a true transition. And this is where I'm going to lean on that moving data from InfraWorks into Civil 3D. You can get the more granular nature of that transition in Civil 3D once you move it over. But the broad strokes of a project can be handled by InfraWorks, and then you get in and do the more nuts and bolts after it's in there. So with that, let me switch over to InfraWorks here. I've got a project that there is a highway here that they're going to add a third lane to, or it's actually just a little outside of the Milwaukee area where I'm from, and they need to widen this up to increase traffic from this particular intersection. So I'm going to select on that series of lanes right there, and now my right click is not going to work. Shoot, I've got lots of cool stuff to show on that too. Yeah, let me open. I did one in here that had videos of each of these just in case something like this happens. So let me just jump in and I will start that video of it there. Actually, I started off with the intersection. So what I did was I selected the intersection and dragged the points back. You can see a turn lane being added, but it adds in the transition there automatically. And even puts in the paint marks in that intersection, so graphically it looks good. Here's where I adjust the lane here. Now, I'm going in and inserting a component. I need to identify that I'm adding a lane component in here. And now I need to be careful where I attach this because you can attach it anywhere. It doesn't know where it belongs, you do. I'm adding that to the south edge of this roadway here. I have to let it compute because it is doing transition work in there. But there, each of those grip points can be moved around. I can change the start and end. I'm going to advance that all the way to one end. And it's like 7,600 feet of lane that I just did there. So again, you don't have to drag that all the way through. I can also change the transition there in and out. I can actually type in how far I want that transition to overlap. In this case, I went a little bit further than that. I was going to make it a 100-foot transition there, but I took it a little bit too far there. Let me zoom in here on a portion of my road that I can add in. I'm going to add in a median, and in here, I'm going to insert a, there we are. I'm going to insert a component. And again, I inserted a lane earlier. This time I'm going to insert an asphaltic median. There is also grass median that you could use out of the box. I'm going to add that in. And again, I have to pick where it's going to be. This is going to be in the center of the roadway. However, medians, lanes don't, but medians have a left, right, and center functionality. So right now that's on the right-hand side. I'm going to go and change that to a left first. And then after that rebuilds itself to the left-hand side and transitions the lanes and the shoulders and so forth, I'm going to go in and change that to a center. And again, just like the lane, you can drag those grip points so you can lengthen or shorten those. I'm choosing to have that median go all the way from the very from the beginning of the road all the way up to this point here, where it transitions back down to an undivided roadway. Something else that I can do in here is I'm going to work on the depth. Now, I'm going to do this for the lane specifically here, but I can split that component, whatever, shoulder, lane, whatever it might be. I can go in and select a station to split it. And there on the portion that's highlighted, I'm going to go into the depth of material there and put in a very shallow depth. And again, this is not a transition. That's a hard cut right there. However, you can then move that over to Civil 3D and work a transition into the differences there. Oh yeah, and I do go into the cross-section view so you can see that through this area here, there's my 4-inch on the right-hand side. If I advance a little bit, and I'll advance through this, you can see that's 4 inches up to a point, and then it becomes 6, or whatever the depth of that material is there. So you can see where that is working there. So with that, let me give you some takeaways to take away from the session today. First of all, alignment and profile targeting is the most basic, and it's kind of the go-to in a lot of cases. However, that new corridor transition tool is, I think, the most effective because you can do so much with it in so many different areas, in fact, along entire lengths of your corridor. And then also the InfraWorks has built-in transitions for a lot of the areas that you're going to be working, but more importantly, it imports into Civil 3D for that nitty-gritty nuts and bolts work that you need to work with. So with that, I'm going to open it up to questions here if we've got time. I want to thank everybody for attending. The QR code is my email address, although I also have that on the screen here as well. So questions? Yes?
So on your corridor transition tool, when you're playing with the depth, can you select more than one sub-assembly for your command when you're changing that depth, or would it have to be separate commands stacked on top of itself?
It would have to be separate commands because each one of those rows or each one of those sections of rows is doing one subassembly. So if you were doing pavement 1 and pavement 2, it's actually kind of created as two different things. So, yeah. That's what you were asking, right?
I think he's asking downstream, by lane 1, lane 2, shoulder, can I push it?
Oh, I see. One of the things that you could do, and I didn't get into the properties of the corridor for that, but one of the things that you can do is tell the subassemblies to use data from something else that comes earlier. So if you have lane 1 and lane 2, or lane 1 and a shoulder, you could tell the paved shoulder portion to access the lane 1 width or slope or depth or whatever it is that you're looking for. And again, some of that has to be programmed ahead of time. A lot of the ones out of the box have all of that set up, but you could set that so that it does that automatically for you. That way, no matter what you've got along your entire length, it's always doing that throughout the course of it. Okay, thank you for clarifying. Are you talking about the ones that you've designed yourself?
I've developed.
Yeah, I don't believe so. Actually, I haven't used it on any of the custom ones that I have. I've only used it on ones out of the box, but I don't believe so. I believe it goes and farms those out.
Okay,
Yeah. Cool.
which makes it even more powerful.
Right.
Usually give you access to stuff that you don't have, driver capability.
Yeah.
As long as you've got it set up to have variable parameters, like if you, in your custom subassembly, if you've got a curb height or whatever it is, those are variable parameters. You'll have the same functionality as you will with the out-of-the-box subassemblies. You can edit those and adjust those however you like.
Cool. Excellent. Thank you. So it is choosing from that as, yeah, that's the decision matrix.
Get those variable parameters in
Good.
order to transition. That's exactly what it is.
Excellent. Good. Thank you. Yeah, in fact, one of the early films that I saw of it was like a curb ramp. And so, doing curb ramps with this, I think it's a game changer. It's, yeah.
So it seems kind of like InfraWorks is kind of the parallel to Bentley's concept station. I guess between the two, which have you found could be like more substantially useful or
Right.
say a consulting firm using it for a proposal?
Okay. I'm going to be fair. I've never used Concept Station. I've seen it. I looked over her shoulder, watched it. So I'm not able to judge that. I will say that at the reseller that I worked at, we would literally arm wrestle over getting to work with InfraWorks because it's fun. It's just one of those tools that's fun. My assumption is the same with, yeah.
Sure. So I know that at least for our company, concept station is kind of a free included package with our openness package. So do you have to buy an additional license for InfraWorks? How's that work?
It's with the,
Infrastructure works.
thank you. Yeah, I'm losing the words here, but yeah, it's part of the package that you can get. Yeah. In fact, that package comes with much more than just InfraWorks too. There's a lot of other tools that are available in the package that you can get. Oh, I'm sorry.
Yeah, just real quick, concept station versus InfraWorks, same functionality. I think the lift from going from an open roads user to a concept station user is a little bit less than coming from Civil 3 to InfraWorks, but you're gonna wanna work in wherever your design is. You're not gonna wanna try and take concept station design and move to Civil 3D. I don't think it's gonna work that way.
Stay parallel. Yeah.
Yeah, just take, sorry, also in the same vein, I'm primarily a Benji InfraWorks user. But sometimes I do have the option, but I find InfraWorks is more functional. You can do a lot more in InfraWorks.
Right.
And it was also, when I was with WSP, this is an enterprise customer, if you're at some of these consultants, you'll likely have an AEC collection license. We never knew about it. Like at WSP, we were only using either open roads or Civil 3D. We used one of the two because, WSP is one of these big players and we never knew we had access to InfraWorks. So find out and you'll figure out what it is. Like Russ said, what I found is that for a preliminary design, it's pretty good. You can do the concept layout. But the thing that I find the best with it is once I'm finished with my design in Civil 3D, I can link that corridor into InfraWorks and then do an aggregated view of, I can have my surface, my corridor, everything in there. And you can see kind of the final rendition, rendering in InfraWorks. So it's really good on the front end. It's fantastic on the back end when you're finalizing and showing kind of a concept view. And I only picked it up just a little while ago and found it's crazy intuitive. So that's
And not to make this about InfraWorks, but I'm going to tell another story about InfraWorks here. I'm a big believer that the public information meeting, InfraWorks, is the tool for that. And this was proven, I wasn't even in the room, so it's not that I'm putting my thumb on the scale here. I won't name the organization or where they were, but they said that they went from days and days or meetings and meetings of trying to get the neighborhood to understand what a change was going to be. And in 10 minutes, and that was they said 10 minutes, they convinced the neighborhood that, oh, that's what it'll look like? Not a problem. 10 minutes they had it done. They had gone weeks fighting and not able to explain to non-engineers what was about to happen. I think I have done sessions like this on using it for public information meetings, just I'm not doing it here this year, but yeah, that's something. Also, correct me if I'm wrong, was InfraWorks out before the Bentley version?
Yeah, it was an infrastructure modeler first.
Right, yeah. So that might also be why you've seen some other things that you can do in it first, because the development time has been a little bit longer. So, and again, not saying anything negative about the other tool, I just don't know it, but if it's been in progress longer, you get a few more functionality things. Things have been learned.
Yeah, but concept station is much easier to learn.
Is it okay? Right.
The other thing with InfraWorks, it's not just on the planning side. Also, I found that when you need to do some good visualizations, those are the packages you can take the InfraWorks model and push it out to like twin motion or motion. So I found you can actually take your final design, like if you have the software necessary with the alignments, take it into InfraWorks, apply your materials there, and push it into whatever visualization
Right.
tool you're using.
Mm-hmm.
I don't think Luminarity has that option. That's the only environment
Oh,
model. So,
right, right. Okay. Excellent. Thank you.
So it's kind of two parts there. So do components, when you're doing your preliminary layout in InfraWorks, something that we haven't really looked at, do components work as sub-assemblies when you link it to Civil 3D? Or the functionality is shared? Like it needs like sub-assemblies?
Yeah, it comes in as a rough assembly. It's not going to be the fully functional assembly that I had, that I was building in Civil 3D directly. It'll come in as kind of a more basic one. But it's very easy to swap those sub-assemblies in and out based on what you need. Like the one that I changed the depth in InfraWorks, that's going to come in as just a pavement. It's not the lane super elevation AOR that has the multiple courses and all that. It'll be just a base material.
Is there an approach component in InfraWorks?
How do you mean approach component?
Like, you guys not use the word approach for like a private approach or on
Driveway.
Oh, driveways. I'm sorry. Yep, yep. It treats it like an intersection, but on a much smaller level. And you may have seen that in the video there. There were actually some small roads as well as some private drives that were connecting to the road along that. And what they had used before they started that project was they put in, I think those were just lanes, but there's some other types of materials that you can make that roadway. You treat it like a roadway, basically. Just a smaller and less developed roadway. And it will transition into what's going on there. Now, sometimes they're a little bit, they're not the prettiest all the time, just depends on how, what you're using and how you're connecting it, but it does treat it like it's an intersection.
So you wouldn't want to use a component from your main line alignment for something like that, right? Because it's like you're gonna have perpendicular like circus ties. You wouldn't be able to do that in InfraWorks?
No, it actually builds an intersection. InfraWorks, I'm going to say, knows what an intersection is. And then when you move that over to Civil 3D, the alignments that intersection would need to target move over. And I'm going to say profiles as well. I'm 99% sure that the profiles come over as well because it needs to target something. Intersections get complicated in a hurry. And especially for something so small, it's handling that complication very quickly. In fact, I'm working with a group on driveways right now in Civil 3D directly, and all the things that we have to do to get that right, InfraWorks just does that for us. So yeah, it understands the geometry that it's trying to solve for and puts in the alignments and profiles as per necessary. So.
Kind of on that, I noticed when you put the median through that it skips that intersection. Is that using a standard or is that editable?
Well,
in InfraWorks?
yes, yeah. What happens is that because that's an intersection, first of all, when I put that in and said go all the way to the start, it literally is going through, and whenever it contacts something that's important, it knows how to handle that. When it gets to driveways and intersections in general, it's going to break that median or break it so that that's open. Lanes go right on through, but medians know, okay, well, I've got to stop there. So yeah, there is and I mean, even if it wasn't doing where you want it, you could select in there and split it just like I did with the lane later. You could split that and break it apart further or have like a control mechanism there. So is that?
Is there an opportunity to carry the median through? So I don't
Yeah.
want to permit.
Oh, don't want to permit that. Yeah, there is. It's a little bit under the hood where you can go in and tell it, okay, in this case with an intersection with this object, I don't want you to break medians. So yeah, so the opposite. Yeah, I was talking about the opposite, but yeah, it is available.
So in InfraWorks, how do you go about
Cul-de-sacs? Wow. I've seen it handled several different ways. One way, kind of the brute force way, is don't put anything in at all, just end the roadway there. And then, like I said, when you move it over to Civil 3D, then you make the adjustment there. Other ones I've seen where they actually did a loop of the roadway around. Not as elegant, but it gets it done. Also, you could take it up to that point and just widen it. Again, not very elegant, but it at least gives you some kind of geometry. It's not round, but I mean, you can handle it kind of in a schematic way, if you will. I'm sorry, surface and shape? Yeah, yeah. Yeah, like instead of a park, you're just putting a kind of an image over the top of it. Yeah, absolutely, good call. I actually haven't seen anybody do that, and that seems like the easiest way. Why wouldn't they do it? If you don't mind, I'm going to borrow that. I'm going to tell people to do it that way. If I don't learn something during a session like this, I count it a loss, so it's a win. We're good. Thank you. Sure, yeah. Yeah. Oh, and there's a lot of development still going on. InfraWorks is not a static product. It's always being looked at and adjusted. So it might be in the works right now. I don't know. I haven't seen anything on it. But, I mean, basically, if it's going to affect enough users, then that kind of bumps it up to the list of things that are going to be tackled next. So,
If you're doing cul-de-sacs though, the recommended approach would be, that I would recommend is, Jeff Bartle showed this method for developing an alignment work design. I've never seen anything like it. Completely blew my mind. And I can share the video with you if you're interested. But I would do the design in Civil 3D and link that to the, and I've done that before, and those look really great as far as having a cul-de-sac integrated with that. That would be the recommended workflow. I would think,
Okay.
and if you're interested, I can share the video. But he like creates this loop around. I've never seen, never even thought to do it that way, and it's brilliant. It's as detailed and as precise as you can possibly be for a cul-de-sac. I always struggle with those things. Hated them.
Right.
This is awesome.
if you see a video by anyone named Bartles, put it in your save list, honestly, yeah. I've learned so many crazy things. He is, yeah. In fact, his AU session is a natural axe, or like, yeah, it talks about doing crazy things with the tools, so.
If you can get into that session, you're scalping tickets because that's
Right,
like
right.
a popular one.
At 12:01 on date, I picked that class. Are we on, are we? Okay, thank you very much, everyone. I appreciate it. Enjoy the rest of IHEEP.